Hi, 3.4 is all about solving exponential and logarithmic equations. Make sure you're using that graphic organizer I gave you. There's a section on there that says procedure in words. I'm not writing that part out. I'm going to be saying that part, but do make sure you still get that part filled in. Alright, for exponential, my process, I'm going to get the exponential by itself, and then I want to take the log of both sides, or put it in logarithmic form. So to get this exponential by itself, I don't know why this is writing. I need to add the 3 to both sides. Equals 22. Get rid of the 2, so I have 5 to the x equals 11. Now that that's all that's on the left side is the exponential, I can put this in logarithmic form. So I have log base 5 of 11 equals x, and then I can actually type that into my calculator. So I'm going to have that x is about 1.490. Couple of things. These you're going to be using calculators on. So there will be a portion of this chapter and this test that you can use calculator. There will also be a portion where you can't, like what we were doing before Thanksgiving and on Monday's quiz. When you type it in, I want accurate to 3 decimal places. So if you're rounding, do make sure you're using that squiggly equal sign. Here, if it loads, is an example for you to try on your own. I am not working this one out. I will, just so you can check it, tell you that you should get about negative 1.846. Next we have if it's just one logarithm. Even though this is a natural log, it's still a log. My process is similar to with the exponential. I want to get the logarithm by itself and then put it in exponential form. So to get this logarithm by itself, I'm going to divide by 3. So I have the natural log of 4x equals 7. Even though there's a 4 and an x, they're both inside that natural log, so this does count as having the entire left side is just the log. When I write this as an exponential form, this is the base e, so e to the 7th equals 4x. E to the 7th is 1096, 0.633 roughly. Dividing both sides by 4, I'm going to get 274.158 roughly for x. Doing this one on your own, you should get that x is about 5.130. Last little section, if you have more than one log, I want to combine the logs on each side so that each side only has one log. And then I'm going to use that one-to-one property that we talked about the other day on Monday to write the logs, to get rid of the logs and just have a solution or a very simple problem to solve. So to combine or simplify this left side, first I need to bring this 2 as an exponent, so this is really like 3 squared. So I have log base 6 of 9 plus log base 6 of x. The right side is already just one log, so I don't have to worry about simplifying that right now. These are 2 logs, both with a base of 6, that are being added, so I can combine them into one log with a base of 6 and multiply 9 plus x. Instead of doing plus, since the logs were added, I multiply, so 9 times x, which is 9x. Didn't change the right side. Now this is where I can use that one-to-one property. Basically, if the log base 6 of this is equal to log base 6 of that, the log base 6's cancel, and I have 9x equals 63, which means x equals 7. As you try this one on your own, your solution, you should get x equals 6 and x equals negative 6, but your domain for logs is 0 to infinity, which negative 6 does not fit in there, so negative 6 would not be an answer. It's just going to be x equals 6. But algebraically, you should get both of them. You just have to remember to check that.